Um, so the name of the session is Set to Take Off, the Burgeoning Space Industry in South Africa. And I want to challenge us to think a little bit broader than South Africa at the moment, because we're talking about space and nothing limits us. Okay, so, and then another challenge. I think we should all start by thinking about when we first heard about space. Think about how old we were or how many decades ago that was and how things were then, just to set the scene a little bit. But we can all agree that it doesn't matter when we knew about space, but at the moment we're experiencing a massive shift in the application of space and the usability of it. Back then, space used to be something that people talked about here and there, but now it's everywhere. It's in our face. It's in our personal lives. It's in when you wake up in the morning and you want to go for a run, you think about the weather. How do we get the weather? Space. And we also think about more critical issues like sustainable development goals, and we see that there is use for space in there as well. So this afternoon, when we think about space, I want us to think about the two segments of space being the upstream and the downstream. And bringing it down into the CSRR, we will be looking at how the CSRR looks at space, both in upstream terms and downstream terms. For those who are not familiar with the two terms, upstream is the people like Vili, and he will be talking about that later on. That's more about the satellite components and the things that people send out into space. And then we look at the downstream components, and that's the Earth observation applications and how space products can be used to make daily decisions and to solve problems that people have on Earth or in relation to space. So, yes, and I was about to say that's where the value is, but that doesn't mean that there is no value in upstream space, because there is a lot of cross-pollination between the two. If you get downstream right, that means that there's something good that's happening upstream. And if something is missing downstream, then it means that we send it back to upstream to look for more answers. So this is just to set the scene for us a little bit and to think about things a little bit broader. We have three very good speakers here with us, and I will be introducing them in a short while. But then the last challenge that I have, it's the afternoon, so we need to keep our minds busy. So while they will be giving their presentations, I want us to think about, now that we have so much data, now that we know so much about space, how can we use space for our benefit in the daily lives of the ordinary people to solve real life problems, to create more opportunities to collaborate, to co-design products, to cross-pollinate between upstream and downstream and everywhere else in between. Okay, so I will be introducing my first speaker, Pontsho Maruping. She will be talking about an investment in space and astronomy. What are the dividends on Earth for developing countries? I'll read a little bit of her bio. Pontsho's career spans both the private and public sector at executive level. She is the Managing Director, Operations and Business Processes at the South African Radio Astronomical Observatory, SARAO. SARAO is a facility of the National Research Foundation and is responsible for managing all radio astronomy initiatives and facilities in South Africa, including the Meerkat Radio Telescope in the Karoo and the geodesy and very long baseline interferometry activities at Hadrao facility. She serves as a member of the board of Mintech and trustees for the NRF Pension Fund. She is the former chairperson of the South African Council for Space Affairs, an agency responsible for regulating space activities in South Africa, and the Science and Technical Subcommittee of the United Nations Committee on Peaceful Uses of Outer Space. Prior to joining SARAO, she was an executive at the Technology Innovation Agency, responsible for innovation, funding, and pre-commercialization support. Her other previous roles include that of CEO of the Mine Health and Safety Council and Chief Director for Space Science and Technology at then DST, where she spearheaded the establishment of the South African National Space Agency. Her educational qualifications include an executive master's in business administration, master's in space systems engineering, Bachelor of Engineering in Management of Technology, Bachelor of Science in Mineral Processing, Welcome, Pontsho.
I mean, I could probably sing, but my daughter has told me I'm not allowed to sing into a microphone unless I'm around people who already love me. So I will not be doing that. But so I mean, I kind of don't really know the audience, so it's a little bit difficult to figure out where to put this. It's kind of strange because normally when I talk about space, it's usually with people that I've already engaged with at some point. But I guess it's a good thing, that there's a whole lot more people involved in space in South Africa. I remember that when we started the engagement on whether South Africa should have a space program or not. In fact, we had an engagement with all of the sectors. There was probably Stellenbosch University doing like direct engineering in space at the time. And then most of the activity SANSA Space Operations, which used to be under CSIR. But all the other players were more astronomy, and I think it is quite exciting for me that in both those areas, South Africa seems to be really progressing. I know that SANSA hasn't had a lot of funding. It's not my fault, I promise. I tried. But yeah, I mean, I think they are starting to do some creative things around, attracting funding into SANSA, and hopefully we'll start seeing a little bit more forward planning. I used to be very envious when countries like India present and they show you their 10-year plan, and there's development projects all over that map. And I'm hoping that South Africa will start doing that, because I think we have some amazing engineering capability in the country that would just take that industry to higher levels. So I know that the session is more about looking down. But I mean, I've kind of been involved in both, looking up and looking down. Or in the radio astronomy field, we say we are listening up. So I'll be talking about both, and probably more about the latter, because I think, in my view, that's probably the best way to do real, meaningful science and technology in a developing country. You can't do it half-heartedly, because then it doesn't have the build up the necessary momentum to create lasting benefits. Then nobody sees me. So I essentially want to talk about two, I guess, very different investment in space that I've personally been involved in. And share my thoughts around, why in some places it's worked better than in others. Okay, so first I wanted to talk about Mandela Set. This is a microsatellite, 80-kilogram microsatellite that South Africa launched a couple of years ago. In fact, the project was initiated as part of rebuilding and re-energizing the space industry in South Africa. Funded by the Department of Science and Technology then, and contracted to Stellenbosch University to, with SunSpace to develop and build the satellite. If you think about South Africa's involvement in space, it's really been, from the 1820s that we were involved in space. We had the Royal Observatory opened in Cape Town. We had the Deep Space Station in Hartbeespoort at SANSA Ops. And then that was used to track satellites since then. And then we even had the first images of Mars received in Hartebeer's book in 1965. So I'm not going to go through all of that. But I mean, it just gives you a sense that it wasn't really these last few years or so is not really the beginning. There's always been some engagement in space happening. And as a result of that, we ended up with some legacy. So the previous government, actually had a proper space program where they were developing a solid rocket launchers and a satellite, an Earth observation satellite. They called it the Green Set at the time. And as a result of that, actually built some fantastic facility for satellite engineering. They used, which was fantastic, a lot of local small engineering firms scattered mostly around Stellenbosch area. And then they also had these facilities for integration, for testing that were to some extent preserved. There's some story about why some of the programs were dismantled, which I guess I can talk about when we have time at the end. So the project objectives for Mandela Set was to have this Pathfinder satellite, to launch it, and then to train some engineers. What we actually got was some really amazing hyperspectral images from this tiny satellite. And that's the image. Unfortunately, I missed the launch because the Russians delayed it for quite a while. And I wasn't at DSI and nobody invited me. Sadly. Anyway, but as a consequence of that, now you have a whole lot of local companies developing components. As I said, it re-energized the interest. DSI started funding some training programs at CPUT, for example. But now we have a whole lot of companies in South Africa that produce components, mostly CubeSat components that they deliver to multiple customers worldwide. We also had, a whole lot of interns trained that we had to find and convince them to leave permanent jobs and go get trained on satellite engineering. And, fortunately, quite a few of them are still working in the space sector. There were a lot of papers for, using the satellite imagery, for example, lots of people trains, and in the end, we, ended up with a strong enough space legacy that you couldn't stop the train anymore. It just really just started, kept going. And in fact, for Mandela, I think there was the image was produced by CSR, if I'm not mistaken. So yeah, so they did involve a whole lot of other entities. Since then, the industry's been growing. We launched Tshepiso Set, which was developed by CPUT in 2013. There were 2 CubeSats as part of the European QB50 mission that were launched in 2017. And they supplied, the attitude. Anyway, I've forgotten what it's called. Anyway, so they supplied components to other teams on the QB50 mission. So it wasn't even just that they did produce their own CubeSats, but they also provided components to other teams, international teams that were involved in that project. And we had almost 100 satellite engineering postgrads developed throughout that period. And multiple spin-off companies, CPUT as a spin-off, Stellenbosch University has multiple spin-offs in the sector. So you can really see that it's really enabled a whole lot of activities to happen. And I guess, this is it just shows you some of the stuff that you need to ensure that all of these things happen. And therefore, a lot of people tend to say, oh, why would a small country be interested in building satellites? Well, because we can, one. And secondly, because there is something to be said about having highly trained engineers in your own country doing some difficult things to do and being very successful at it. It's an exciting sector for young people to get involved in, and we will do it for that reason. And then, as I said, then you have all these other things that make up what happens in the sector, which has actually happened. So another example that I wanted to talk about it was the SKA project. I hope most of you know what it is. Essentially a radio astronomy project built in South Africa and Australia with the headquarters in the UK. The first phase of the project, both South Africa and Australia built their precursor instruments. So we have a 64 dish array in the Karoo, and Australia have a low frequency array in the middle of Australia somewhere. And the next phase, and by the way, our instrument is already working, so the next phase is part of the international project. Because it's an array, the more dishes you add, the better you improve the instrument, and therefore, we already have a really great instrument, but it will continue to get better with time. So, I guess I've been given a little bit of the history, both astronomy and space, but, in particular in astronomy. So SAO recently celebrated their 200-year anniversary, and for some time, actually, they were the only telescope of that type in the Southern Hemisphere. SALT, which Southern African Large Telescope, is an international project with external partners, and therefore brought in, additional investment in the country. And I've already spoken about the dish at Hatrao. And then as Serao, so we started with Cat 7, so a 7 dish array, and kept building up. Now we have the Meerkat telescope operational, and then we are going to now be going into the SK itself. As you can see, it's a huge investment in a major international project. And then there's, within the African continent, in Namibia, for instance, there's also the gamma ray astronomy. So, and South Africa also, approved a multi-wavelength astronomy strategy that provided some of the policy and the funding that's required to implement this project. So why would you do a project like that? Well, we have the geographic advantage. The Karoo was chosen because it's radio quiet, so not too many people on networks that do create a noise for a telescope like that. It's extremely sensitive. You do it to, push your, I guess, prestige in terms of scientific outputs. It pushes the boundaries in terms of technology. It allows you to build skills, and you can also have socioeconomic returns. And I'll share some of those that South Africa will experience. I'm gonna skip this because it kind of repeats more or less the same thing, but it's just, how do you measure whether this type of investment is giving you the results you need or not. So these are some of the images from site. So this is actually an SK dish. We have 64 of those in the Karoo. We're actually already building an extension with the Germans, and they'll be putting in 13 to 16 additional dishes in the Karoo. One of them has already been commissioned and is doing a single dish science already. And then we have this data center that we've built because this type of instrument generates huge amounts of data, and therefore we need to be able to process that data. We've had some fantastic research outputs. One of the amazing things about South African engineering is that that telescope worked what you could imagine almost out of the box. Essentially, we switched it on, everything had been tested, and we're able to start using it. So lots of scientific outputs already. More than 16,000 hours of science observations for 250 projects. So, and I hope some of you have seen these images that have been, highlighted all over the world in terms of how fantastic the instrument is. And, we've increased the astronomy community in South Africa. So from the get-go, we had a human capital development program that gives bursaries to students that go into science, engineering, and technology. In addition to that, I wanted to kind of mention this, and I guess it's also part of why would you do it. So our engineers actually worked on the National Ventilator Project, where we coordinated during COVID production of ventilators to be used in our hospitals. In fact, one of these, I think this one is a CSR device, and there were a few other companies that were involved, only because you have, mechanical engineers, systems engineers, electronics, electrical engineers, having that, a cohort of people like that, allows you to do these type of things. So Sarao was project managing that. We have some products such as the digitizer that we are now looking at its application in telecoms industry. We, as I've already mentioned, huge compute and storage requirements for the telescope, to a point that we couldn't buy OEM produced systems. It just would have been completely unaffordable. So a lot of our compute and storage is off-the-shelf components with open source software to make it work for our requirements. And then we have in partnership with a local company, also worked on some products that are needed. So this is a commercial radar system to monitor flights above our site, which is already operational on the site. So we use it because we need to monitor flights that might interfere with the operation of the telescope. We've also been able to attract external collaborators. We already have a site that's radio quiet, that's serviced. So it's attracted a whole lot of other projects. The HIRA instrument, very basic, made out of wire mesh and wooden poles, used a whole lot of local companies and hired a whole lot of people in that community to build. And then it's funded by international partners, and we'll probably be doing science soon. So it's not meant to be an instrument that lasts for long, but it's attracted investment into the Northern Cape, and this just gives you a sense of where most of this money was spent. But it's also provided for training as well in using the instrument. So the next phase, as I said, is to do the international project. To do this, South Africa will be able to attract some direct contracts. So this is a return that essentially comes to South Africa, and this just gives you a sense of the number of projects. This is a local company that's doing software development for SKO, directly contracted by SKO. We have an AIV contract that there's already been awarded to Sarao to provide support for assembly integration and verification for SK Mid 1. So, a 15 million euro contract that Sarao is already implementing. So we are estimating that just for South Africa, we will be able to bring in 150 odd million euro, and either in mostly in direct cash that will come either to Sarao or to the companies. And I think the good thing was that we also made sure that South Africa doesn't get contracts just to dig holes in the Karoo. I know we are good at digging holes, but we wanted to make sure that we actually build high-tech systems as well. And that's why we've made sure that we keep a strong technical team internally. We've also done quite a lot of HCD, same as the Sumbandila. Every project, if you don't look at especially the human capital development, you can't sustain it because it's the people, the new ones, the ones that are already working that allow for the knowledge and experience to grow and be retained in the country. We also do in the Karoo provide bursaries for high school learners. We hire STEM teachers for the high school. We've given, bursaries to local learners. We've done programs like robotics, and one of the teams in the Karoo actually won an international competition in robotics. So I think we're bringing the type of things that you normally wouldn't expect in those little towns. I think so. In addition, now we've also looking at things like supporting, sports activities in the area through some small grants. We've done a comprehensive SMME training and support, and in fact, for the current contract, construction contract, some of the SMMEs that we trained were able to be subcontracted by the main contractor. And we'll continue to do that for them so that, you don't, you allow those communities to become sustainable as well. We support the municipality in the Karoo, and there's huge tourism potential, even though it's a little difficult for a radio telescope to do that because we don't necessarily want people and their interfering instruments on our side. So, but yeah. I think that this is not very clear, but I think this was just to give a sense of, you need all these elements, the people, the infrastructure, the systems, and the right level of funding to be able to have that impact. So I think that also what I wanted to demonstrate is that when we talk about investing in space, the money doesn't go to Mars, right? It gets spent here on Earth and therefore generates all these economic benefits for the country. And that's the reason African countries should definitely consider spending money in space. Thank you. Questions?